Okay, here's a few of the problems from that review worked out, just so you can, if you're having trouble with them, you can see what to do. So on number one there, the key is draw it out. What's happening before the collision, and I did this squiggle, and this is after the collision. So before, this guy's at rest, this guy's moving -4 meters a second, and then after, they're both together, and I don't know their velocity, but I do know I put 5.8 here because together they're 5.8 kilograms. Because then it's pretty easy. You just got to write out an equation. I do 8 times 0 plus the 5 times -4. That's momentums, right? Total momentum here equals, and then I do the total momentum after, which is just this mass times v. Okay, so that's a setup, and then it's just an algebra equation where, you know, I multiplied this out and added them together, got -20, and then kept solving for v. So I got down to v is -3.4. And then the flip side of that, I didn't draw the picture for this, but it said something like, well, what if the little fish here was going 4 meters per second to the right? So basically it changes this 0 to a 4. So right here, momentum of the little fish, momentum of the big fish. This is the momentum together after the collision, mass times velocity. And then you work it out like an algebra equation. So in that case, got down to -2.9. Okay, show you number 2. 2 is kind of similar, except they're together before it's not a collision, it's actually like an explosion. I guess you say they're together and then they're apart. So we're going to do this equals this momentum. Okay, so you could have added these together and said 94 times 6.5. I did them separately in this case. So I did 80. The guy's 80. He's going 6.5. The dog is 14, and the dog is going 6.5. They're both moving together at 6.5 before. Okay, that's what the wording of the problem was. And then after, it said the dog goes -10.5 south. I did south as negative, north is positive. So the dog is the 14 times -10.5. The guy is 80, and we're trying to figure out how fast he's going. So it's just m times v, m times v. You know, this is before, this is the after. Okay, and then it's just a matter of solving that out. I just kind of multiplied this, and added them together. Multiplied these, you know, kept working it out there. Okay, got down to 9.5. The other part of that was what's the impulse on the man, I believe, what's the impulse on the man while he's throwing, and then what's the impulse on the dog total while they're being thrown. Well, impulse is change in momentum. Okay, that's the big idea. Impulse is change in momentum. So I figure out the momentum of the guy here, and then I figure out the momentum of the guy at the beginning, and I subtract those to figure out the change. Change is always, well, how did you end minus how did you start? So I found a momentum here. I didn't show it, but I did 80 times 9.5. Okay, that was how fast he was going here, right? So momentum of the man at the end is 760. Momentum of the guy at the beginning is 80 times 6.5, right? Which came out to 520. So I minus those, the change is 240. Now for the dog, same idea, find the momentum of the dog here, and then find the momentum of the dog here, and I'm going to subtract those. So here I did -10.5 times 14, -147. And then here I did 14 times 6.5, got 91. So I subtracted those, so it's a negative minus a positive, so actually it came out to -238. These should come out the same. The reason they're different is because of rounding. Okay, I'll show you just one more. Let's see. Probably that one with the clay. Which number was that? I think it was number 6 here. So there's the clay and the ball. Okay, so the ball I said had a greater change in momentum. I mean, that's kind of obvious because the speed changed by more. So looking at the change in momentum, yeah, pause just a second. All right, on number 6 there, it said one of the balls, I think they're 10 kilograms. They're hitting a wall and then one's bouncing back. And then the other is a ball of clay that just comes to a stop there. So let me look here. The velocities were, I'm sorry, 2 kilogram ball, or 2 kilograms. And this is going at 10 meters per second, going back at 8, so -8 here. And then this one's going at 10 meters per second, and then just coming to a stop, 0 meters per second, okay? So then the question was, which one has a greater change in momentum? Well, if you calculate it out, this is 120, right? Kilogram meter per second. And then what's this, -8 times, oops, sorry, not 120, just 20. This is a 2 times 10. And then 2 times 8, this is -16 here, kilogram meter per second. Okay, so the change from 20 to -16 is like -36, right? This one's going from 20 kilogram meter per second down to 0 for the momentum. So from 20 to 0, that's a change of -20. So the change here went down 36. This one went down only 20. So that's why I say the ball had a greater change in momentum. Then it says something about to find the force on the clay when it comes to a stop, and it says that stopping time is 0.2 seconds. So let's find the change in momentum first. It ended at 0, it started at 20. So to find a change, you just subtract. The change is -20, right, for the impulse. And now you're going to say impulse is force times time. So -20 goes here. That's a change in momentum, or the impulse. We don't know the force, and it told us the time is 0.2. So if you divide each side by 0.2, you get -100 newtons. And I said, oh, what if the time for the clay to come to a stop, like the time for it to like smush and come to a stop here was 0.3 seconds. So it's similar. The change in momentum is still -20, going from 20 to 0. Now the time though is 0.3 seconds. So I divide each side by 0.3 and get this. So there's less force here because it's like took more time to stop. There's more force here because it stopped faster.